Welcome back. In this section, we're going to be looking at two very important differentiation rules. The product rule, when we have a function that could be thought of as a product of two smaller functions, or the quotient rule, when we've got a function that could be thought of as a quotient of two functions. So here for the product rule, if we have two functions, f of x and g of x, and both of them are differentiable, and we want the derivative of f times g, the product rule tells us that it's the original function f as it is times the derivative of g plus g as it is times the derivative of f. So let's prove this. Let's show where this comes from. And like everything else that we've done so far for these proofs of differentiation rules, we're going to start off with our limit definition. So if we're looking for the derivative of f of x times g of x, then that's the limit as delta x approaches 0 of my function at x plus delta x. So that would be f of x plus delta x, g of x plus delta x, and then minus f of x times g of x. And this is all over delta x. Okay. For both of the theorems that we're going to see today, the theorem for the product rule and the theorem for the quotient rule, the proofs both have a little clever trick where we add an amount and subtract an amount. That's the sort of clever trick that will take us from what we currently have to something where we'll get to our conclusion for the product rule. So what I'm going to be doing is taking what I currently have and adding in and then subtracting the same quantity. So here I'm just going to get everything set up as what I currently have. So I've got f of x plus delta x, g of x plus delta x, and I currently have a minus f of x, g of x at the very end. And so what I'm going to do is in the middle, I'm going to subtract and add the same amount. In particular, I'm going to subtract f of x plus delta x times g of x, and then I'll add that back in, plus f of x delta x times g of x. Almost didn't have enough room, but I just made it in. So why did I do this? Well, if we take a look at what I currently have now, I can see that in the first two terms, I have an f of x plus delta x that's in common, and then I'll be able to factor them out of the first two terms. And what am I going to be left with? Well, it'll be a g of x plus delta x minus a g of x, which hopefully you'll recognize that as the start of our derivative for g. And same thing with the last two terms. I can also see that I've got something in common there. In particular, the g of x. I'll be able to factor a g of x out of both terms, leaving an f of x plus delta x minus an f of x, which, again, that's sort of the start of where our derivative of f is going to come into play. So let's continue this on the next slide. Let's do that factoring. From the first two terms, I'm going to factor out the f of x plus delta x. And what was left behind was g of x plus delta x minus g of x. From the second two terms, I was factoring out g of x. And what was left behind there was f of x plus delta x minus f of x. And this was all over delta x. So what I'm going to do now is do a little bit of splitting things up. You can see that in the numerator I have two big terms all over delta x. So I could split that up into two little fractions, both involving delta x as the denominator. So I'd have that first part of the numerator over delta x plus that second part of the numerator also over delta x. And there we go. We are almost finished. Because if you're now taking a look at what we have, you can see that we've almost got what we need. I can see that I've got a g of x plus delta x minus a g of x all over delta x, and here I've got an f of x plus delta x minus f of x all over delta x. That's where the g prime and the f prime are going to come from. So I'm just going to do one last little bit of making things really obvious for whoever reads this proof. Of course, that's the reason why we're taking good care to write things as nicely as we are, because again, the whole point is somebody might want to read and understand why things are the way they are, so we want to make sure that when we go from one step to the other, it's pretty obvious what we did. So what I'm doing now is for both of the two fractions I have in the numerator, two things multiplied, and so of course I could split it up as one part of the numerator times the fraction. So essentially I'm taking the f of x plus delta x out in the first fraction and taking the g of x out of the second fraction. And now we're pretty much good to go, because if we're remembering our favorite limit law, which told us that if, or collection of limit laws rather, that told us if we had some sort of an expression and we were looking at finding the limit, and if it was broken down into individual parts, each of whom had a limit that existed, then we could just find the limit of all those individual parts. As delta x goes to 0, f of x plus delta x, that has a limit. That's just f of x. The little fraction that I have here, that's the difference quotient for g. So as delta x goes to 0, we get g prime of x. G of x, there's no delta x's involved, so as delta x goes to 0, it is just g of x. And for this second part, we have our fraction again that's a difference quotient for f. And so as delta x goes to 0, that becomes f prime of x. And there we go. We've established our product rule, and now we're ready to use it. So I've got a couple of functions, and for each function, I'm going to find the derivative, and then I'm going to simplify as much as possible. Sometimes there's a limit to how much simplification you'll be able to do, and we'll also talk about in some examples about when we might not bother to simplify. But this one, we do want to simplify, so let's get ready to go here. If we're looking to find our derivative, f prime, I notice that I've got a product. I have things that are pretty clearly one thing times another. So I'm going to be using my product rule, and maybe for the first couple of times that you do it, it might be worthwhile to do what I'm going to do, which is actually write out first thing as it is multiplied by derivative of the second part. So here I'm not actually taking the derivative yet. I've just written down the derivative with respect to x of that second factor. And I'll save doing the derivative for the actual next line. Okay, plus that second factor as it is, 4 sine x plus cos x times the derivative of that first factor, the derivative of 3x squared minus 7x. Okay, now I've set it up using my product rule that said we were going to, for f and for g, that the derivative would be f times g prime plus g times f prime. So I've got things set up, and now let's actually do the derivatives. The derivative of that second factor, derivative of 4 sine x, derivative of sine is cosine, so we'd have 4 times cosine of x. Derivative of cosine is negative sine of x. And then for the second part, derivative of 3x squared minus 7x. For the derivative of 3x squared, the 2 comes down, and 3 times 2 is 6. When I reduce the power by 1, 2 minus 1 is 1. Minus 7x, the derivative of x is just 1, so the derivative of 7x is just 7. So now I don't really have much that I can really do here, except I could, and this is my plan, I'm going to expand and expand those two brackets, and then I'll be able to combine together things according to whether they have sine or cosine in them. So in the first two brackets, just expanding, I've got 12x squared cosine x minus 3x squared sine x minus 28x cosine x plus 7x sine x. And in the second bracket, when I expand that, I'll have plus 24x sine x minus 28 sine x plus 6x cos x, and then minus 7 cos x. And so I guess what I'm going to do now to finish things off is just combine the terms that have take the terms that have cosine involved and factor a cosine out of all of them. So if I'm looking at these, I can see I've got a 12x squared cosine of x minus 28x cosine of x, plus 6x cos of x, and a minus 7 cos of x. So if I were to take all four of those terms and factor a cosine of x out of all of them, I would have 12x squared minus 28x plus 6x and minus 7. For the remaining four terms, those all have sine involved, and if I were to factor sine out of all of those, I would have minus 3x squared and plus 7x plus 24x, and then minus 28. And then I guess the last thing that I'd probably want to do is just to combine the common terms that I've got here. I've got the minus 28x plus 6x that I could turn into minus 22x. And for the second bracket, I've got the 7x and the 24x, which I can add to give me 31x. And there we go. I think that's about as simplified as I can get for that. And so that's where I'll leave my first derivative. Okay, so one more. And so for this one, I've got two terms, and in each of the terms, we have a product. The first term is 3x squared times cosine of x, so I'll have one product rule to do there. And then I'll have another product rule to do for that second term. I have 2x times sine of x. So as I set things up for my derivative, I'll say it'll be the first term as it is, or the first factor as it is, times the derivative of the second. And again, I'm leaving the actually doing the derivative for later. I'll come back and figure that out in the next step. I'm just sort of formally setting up who's taking the derivative when and where. So second thing as it is times derivative of the first. There we go. So I've taken care of that first product, and now plus, and let's take care of that second product. First thing as it is times the derivative of the second thing plus the second thing as it is times the derivative of the first part. Okay, so now we're pretty much good to go. We just need to now do all those little derivatives that we said we were going to do. First one being the derivative of cosine, and the derivative of cosine is negative sine of x. The next one, we've got the derivative of 3x squared using my power rule. The 2 comes down in front. 3 times 2 would be 6, and when I reduce my power by 1, 2 minus 1 is 1. So 6x is the derivative of 3x squared. For the next term, I've got 2x times the derivative of sine, and the derivative of sine is cosine of x. And for the last term, I've got sine of x times the derivative of 2x. And for 2x, the derivative of x is 1, so the derivative of 2x is 2 times 1, which is 2. So I guess I'll do the same sort of thing that I did for the last one. I've got some terms with cosines and some terms with sines. So if I were to factor out sine from the two terms that have it, I would see that I would have left behind a negative 3x squared and a plus 2. And then if I were to take the two cosine terms, I can just see that they can be added. I have 6x times cosine plus 2x times cosine, and that'll give me 8x times cosine of x.